In this video, we're going to find partial sums of the given series, 7 plus 13 plus 19, so on and so forth. So we're first going to find the 10th partial sum, and we're going to go over all three ways that we've done this in class. The first way is the least efficient, and that's just by simply finding all 10 terms and adding them together. So you can see that this is arithmetic because we are adding 6 each time to get the next term, so we're going to continue that pattern to get all 10 terms. And so then we'd have 25, 31, 37, 43. So we're at 1, 2, 3, 4, 5, 6, 7 terms. We need 3 more. 49. We would have 55 and 61. So now that we have all 10 terms, we could simply just add them all together and we would end up getting 340. Now, this is initially how we found partial sums because we can actually see all 10 terms and add them together. Clearly, it's not the most efficient, especially if here in a second I'm going to find the 100th partial sum. So the next method we learned to find the 10th partial sum was to come up with the formula and use the summation in our calculators. And so we tell our calculators to start at the first term, to calculate the sums all the way through the 10th, but then we have to give it a formula to find each term. And so we are starting with 7, our common difference is 6, and to get the second term we add 1 6. To get the third term we add 2 6s. So the number of 6s we add is always 1 less than the term we're searching for. So from here, you can either use Desmos or you can use a graphing calculator. If you go to Math 0, you get the same summation. So you have x equals 1. Our calculator uses the variable x instead of n. We're adding through the 10th partial, or through the first 10 terms. And so we type in our equation now. Minus 1. And we get the same exact number, 340. Now, this tool is definitely great. It's quick, it's easy. However, for working backwards, it doesn't help. And so we looked at 2 different sum formulas in class. Depending on what information you're given will depend which one you want to use. This first one, I need to know the 10th term. So if I didn't feel like making this list, if I didn't already know that this was 61, I would probably want to use the second one. So I'm going to go ahead and use the second one to find the 10th partial sum. I'm going to take n divided by 2, so 10 over 2 times 2 times the first term, which is 7, plus my common difference, which is 6, times n minus 1, and again, n is 10, minus 1. So I will end up getting 5 times 14, 10 minus 1 is 9, times 6 is 54. So I will end up with 68 times 5, which we end up getting 340. So really any of these methods will get us to the right answer, but again, these last 2 are going to be the most efficient. So now we're going to use the most efficient method to find the 100th partial sum. And again, whatever is most efficient to you, whether it be this second one or this third one, really that's going to be your choice and your preference. I'm going to go ahead and use the summation. And so I'm going to set this up. I'm going to tell it to start at the first term, add through 100 terms, and again, we have to give it our equation. Okay, so this time I'm going to go ahead and use Desmos. So in Desmos, when you go to type this in, you'll go to Functions, Miscellaneous, and then there's that Greek letter sigma. We're telling it to start at the first one, count through the first 100. And now when you go to type in your function, it's not going to give you an answer unless you put your function in parentheses. So you'll want to make sure that you do that. And so again, we are starting at 7, and we are adding 6 each time. I'm going to change this a little bit to make sure that you're in parentheses. So 7 plus 6 parentheses, and we have our n minus 1. And then I'll need to delete this stuff over here. And so we end up getting 30,400 as our answer. We could quick verify this if we wanted to. using this formula right here, we could take 100 divided by 2, which is 50, times 2 times our first term, which is still 7, and then add that to our common difference, which is still 6, times 100 minus 1. Looks like I got an extra 0 there. And so we end up getting the same answer, so we are done.